Alright, so this video is going to help you with the Dosage Lab. So I'm looking at lab 14. You can see here the dosage calculation lab. So for this lab, you don't need any data. It is just a conversion lab, practicing your conversions using medications. So this will really help if you're going into nursing school. We're going to be doing some calculations similar to nursing school. I want to point out that you are given a conversion factor table, as you can see here. So use these conversion factors when necessary on the questions. There's also a key over here with the abbreviated units. So I want to point out for gram, they use GM instead of just G like we've been using in class. So just be aware of that. It's still gram. Also notice that there is a grain, GR. These are not the same thing. Okay, there's even a conversion factor, if you look over here, going from 1 grain to milligrams. Okay, so pay close attention to the units and use the appropriate conversion factors. So what I have done is I've prepared a few questions similar to what you're going to see in this lab. So I'm going to work through those so that when you approach questions like it, hopefully it will help you get started and figure them out. So ignore my sloppy handwriting, but we have a doctor ordering 40 mcgs every 12 hours. So the dose is 1 milligram per 100 milliliters. That's the dose that's available. So how many milliliters are you going to give the patient? Okay, so whenever you see a fraction like this, so 1 milligram per 100 milliliters, that is a conversion factor. So that's a conversion factor that you're going to be using to solve this problem. So I'm going to write it in conversion factor form. So 1 milligram is equal to 100 milliliters. So that's going to help me. Okay, that's going to help me get from milligrams to milliliters, because that's what I'm trying to get in, is milliliters. Okay, but notice I need to be in milligrams in order to get in milliliters. Well, let's look at the other information they've given us in the question. They've said we need 40 mcgs every 12 hours. Now in this particular question, it's just asking us how many milliliters per dose. So that 12 hours, we're not actually going to use that for anything. So they're just telling us how often. But the other piece of information we have is this 40 mcgs. So we're going to approach these just like our regular conversion problems, where we're going to do dimensional analysis, that railroad track method, and this 40 mcgs, that's what's going to start it. That's the unit that we're going to convert. Okay, now we don't want mcgs. mcgs being a microgram. We want milligrams to use this conversion factor. So we're going to have to convert mcgs to milligrams. Okay, so that's where this chart's going to come in handy, because we have micrograms and milligrams right here. So we're going to use this conversion factor to get us between the micrograms and the milligrams. So the other conversion factor we're using is 1,000 micrograms is equal to 1 milligram. So now I have the conversion factors I need. When I go ahead and start my railroad tracks, what's going to start it is this microgram, the 40 micrograms, because I'm trying to figure out how many milliliters we're going to give the patient. I'm going to use this conversion factor first, putting the micrograms on the bottom so that they're on opposite sides of the horizontal line and will cancel. That'll put my 1 milligram on the top. Now, I can use this dosage that they gave me, the availability, as a conversion factor in my next spot on the railroad tracks to go from milligrams, which is what I'm in now, to milliliters. I can do that by putting the 1 milligram portion on the bottom, opposite sides of the horizontal line, cancels out the milligrams, and then I'm going to put the 100 milliliters on top. So notice I've canceled out all my units except for milliliters. So once I calculate this out, my answer will be in milliliters, and I'll know how many milliliters to give the patient. When I calculate that out, I get 4 milliliters. So that would be your answer for that one. So let's look at another one. So the next one that we're going to look at is a doctor prescribing a 50 milligram per kilogram dose every 8 hours to a patient weighing 150 pounds. So how many grams would the patient receive for each dose? Okay, well, remember, this is a conversion factor, so I'm going to write it as such. So 50 milligrams for every 1 kilogram that that person weighs. The weight we have for the person is 150 pounds. Okay, but this dosage, this 50 milligram dose, you're supposed to give 50 milligrams for every kilogram the person weighs. Well, we don't have the person's weight in kilograms, we have the person's weight in pounds. So we are going to have to convert that to kilograms so that we can use this dose and administer it correctly. Okay, so I'm going to look up a conversion factor to go from pounds to kilograms. Is there one on this sheet? There is not. Oh yeah, it is. There it is. 1 kilogram is 2.2 pounds. Okay, so what are they asking? How many grams would the patient receive? Okay, so they're asking for an answer in grams. So what do we have here? Well, we can go from pounds to kilograms using this. We'll then use this conversion factor to go to milligrams. But they want the answer in grams, so we need yet another conversion factor. So to clear this up, let's label these. So conversion factor 1 for the first step, conversion factor 2 for the second step. Conversion factor 3 will be for this step here, so I need a conversion factor. Okay, metric to metric. So you can use your metric tables that we've used so far, or you can use this. You're going to get the same answer. So milligrams to grams. There we go. Remember, GM is grams, so 1 gram is equal to 1,000 milligrams. Okay, so I have everything I need to get all the way from pounds to grams. Start my railroad tracks. It's going to be a big one. I start with the 150 pounds, the weight of the patient, because I'm trying to figure out, based off their weight, how much medication I need to give them. So I'm going to start with the first conversion factor, putting the pounds on the bottom, because I want to get rid of pounds. I need it in kilograms in order to administer the correct dose. So this is step 1. If I stop here, I'll now be in kilograms. So then I can use the second conversion factor, putting the kilograms on the bottom. This is going to get rid of the kilograms. So now I'll know how many milligrams to give the patient. But I'm going to continue. I'm going to keep going because I want to know how many grams. So putting 1,000 mgs on the bottom so that the milligrams cancel, and then 1 GM on the top. So now multiply all the way across, divide by what's on the bottom. So I'm going to get 150 times 50 divided by 2.2 times 1,000. So I want to give that patient 3.4 grams. All right, let's look at another one. So here we have a patient is given an IV with a dosage of 25 milligrams of medication delivered over an hour. The med was available in this dosage. how many milliliters should be delivered over the hour, how many per minute. Okay, so two different questions we got to answer. Let's just start by identifying the information given. Let's make our list, make a plan. So we have 25 milligrams of medication is what they're trying to give. So I have a feeling that this is the number that's going to start our railroad tracks. Okay, next we have that the med was available in this dose. Okay, notice the slash, that's a conversion factor we're going to use. So 0.50 grams for every 100 milliliters. So if I have 100 milliliters, that means there's 0.5 grams of medication in it. They want to know how many milliliters should be delivered over the hour. Okay, so notice the dose that we need to give the patient is 25 milligrams. It's in milligrams. Our conversion factor, however, is in grams. So we have to get it in grams before we can use this. So we know there's going to be a step here to go to grams. Once we're in grams, we can use this conversion factor here, let's call it conversion factor 2 since it's for the second step, to get us in milliliters. Now this will be the milliliters that are delivered over the hour, because it says 25 milligrams of medication over the hour. So once we get this answer, that'll be over the hour, and then we'll further convert it to figure out how many mils per minute. Okay, so before we get into that, let's find a conversion factor for this first step here, going from milligrams to grams. So there are 1,000 milligrams that we saw in the previous problem in 1 gram. Oops, getting thrown by that extra M that they use in the Dosage Lab. All right, so we have what we need to answer the first question. So let's do our railroad tracks, starting with that 25 milligrams. Oops. It's not a very good eraser. 25 milligrams. All right, so first conversion factor, put the milligrams on the bottom, the gram on the top. So now we know how many grams to give the patient, but we want to know how many milliliters, so the second conversion factor will get us there, putting the grams on the bottom this time, and the milliliters on the top. So now, when we do this calculation, we'll know how many milliliters over the hour. So times 100 divided by 1,000 times 0.5. If you see any mistakes, please let me know, because when I'm entering this in my calculator, I'm kind of trying to do it quickly, so there is a chance I might forget a 0 or something here and there. So this is 5 milliliters per hour. So I want to know how many per minute. Okay, now this 5 mils per hour, that's like saying 5 milliliters per hour over 1 hour. Okay, so I'm going to start here. So my 5 mils is my railroad tracks, but on the bottom this time I'm going to write 1 hour, because that's how many milliliters over 1 hour, and I want to get into minutes. So I'm going to need a conversion factor here to figure out how many per minute. So how many minutes are in an hour? 60. So let me write that over here. So this is the conversion factor that I'm going to put here to cancel out hours and get minutes. So this time the hour is going to go on the top, because my goal is to get them on opposite sides of that horizontal line. It's going to put my 60 minutes on the bottom. So to figure out how many mils per minute, I'm just going to divide 5 by 60, and I get 0.08. Technically should be 2 sig figs, so we'll do that. And that's how many mils per minute. Okay, let's try another one. So next we have a problem where the doctor is prescribing a medication, and this is new. So that's why I wanted to do one like this. 20 milligrams per kilogram per day. Okay, so that looks like a very confusing type of conversion factor. So let me just show you how we're going to write this out. And I'm missing a piece of information. I should have the weight of the person here. So let's say it's a kid and they weigh 25-pound child. Okay, because you will be given the weight if you see a question like this. So this is similar to number 12 and number 13 on your lab 14. So they do give you the weight, so that's why I added that in. Okay, so now let's focus on this conversion. So how do I represent that as a conversion factor? Well, it's like saying 20 milligrams is equal to 1 kilogram per day. Okay, so what we're going to try to figure out is we need to see how many milligrams we're going to give this 25-pound child for each dose. Okay, so let's start by writing down the information we need. So we have a 25-pound child. We can use this conversion factor to figure out how many milligrams to give that child per day. Okay, because it's saying that they need 20 milligrams for every kilogram that they weigh per day. Well, in order to use this conversion factor, the child's weight isn't in kilograms. The dosage is saying giving it to us in kilograms. So we are going to need to convert to kilograms first. Because once we know the child's weight in kilograms, we can use this dose to figure out how many milligrams to give the child, and this will be milligrams per day. Okay, so this will be the second conversion factor we use. That means we're going to need a conversion factor here. So the first one will be that 2.2 pounds is equal to 1 kilogram that we saw a little while ago. Right, so let's write this out. Starting with the weight of the child, 25 pounds. Converting that into kilograms by putting the pounds on the bottom. So now we're going to know how much the child weighs in kilograms. Then we'll use the dosage, putting the 1 kilogram per day on the bottom, and then the 20 milligrams on top. So notice the kilograms are canceling, but the day's still there. So the reason the day's still there is because once we get this dose, that's the dose that they need to get for the entire day. So 25 times 20, multiply across the top, divide by what's on the bottom, 2.2. So per day, this child needs to receive 227 milligrams per day. Okay, this is not the final answer. That's why I'm not even worried about sig figs here yet, because we need to figure out how much to give the child every 8 hours. So, how much do you think we should give the child every 8 hours? So let's think about this. There are 24 hours in a day. So if you divide 24 hours in a day by 8, so why am I dividing it by 8? Because I want to know how many doses to give the child total. Okay, so 24 hours in a day, if I divide it by 8, what I get is 3. So what does this 3 represent? That means I need 3 doses to give the child. Okay, well, I have 227 milligrams per day, but I'm going to separate that into 3 separate doses. So to figure out how much every hour, I'm going to divide the milligrams by 3. And that tells me that each dose, every 8 hours, I'm going to give the child 75, I'm just going to round up to 76 milligrams. So you could write it as per dose, or you could write it as every 8 hours. However you'd like to do that. All right, so I've only done 4 problems, but if you look, a lot of the problems are similar. So I kind of skipped over the easier ones. Like for instance, on the pre-lab, this first one is having you go calculate how many teaspoons are in 30 mils. So you would just find a conversion factor getting you from teaspoons to milliliters, and it's just a one-step problem. Okay, then it gradually builds up. So if you have any questions that I did not cover, please let me know. Send me an email. I can always supplement this video by doing some more examples.